Hello, this is Ivory Wilds. I'll be giving a brief presentation on leading attrition factors as it relates to a company that has lost some members and would like to have a better understanding as to why. First, we'll understand the data. I found that the data was able to be split into two specific types: personal factors and employee-related factors. Personal factors to include gender, age, marital status, and employee factors, including things such as overtime levels and stock option levels. So the goal here was to identify the factors that led to attrition, isolate the three most impactful, to key in on any job-specific trends, and then later on to use the models to predict missing attrition and monthly income values in two separate data sets. I used four specific machine learning techniques to train the models, and those techniques were naive Bayes, k-nearest neighbor simple linear regression, and random forest. Right off the bat, I found that overtime, stock option level, and job roles seemed to be the most significant factors that led to attrition. And I say this based on the fact that 57% of the members that did leave worked overtime, 70% of them had stock option levels at near zero. And I also found that the job role of sales representative was a significant impact on attrition. So in the analysis, I was able to use the R-squared value, which is relatively dependable when you're dealing with models with multiple variables. So I systematically added a variable one at a time and then took note of the R-squared value's response. With naive Bayes predictors, I used a pretty large sampling of predictors. The majority of those predictors were work-related versus personal. And with that model, I was able to achieve an accuracy of 86 with a sensitivity of 94 and a specificity of 0.52. You'll notice that it successfully identified 25 of 37 members that did leave, which I found to be extremely useful later on in my analysis. With k-nearest neighbor, I was able to use a smaller number of predictors, and they were also very employee related, where marital status was the only personal predictor. Using this model had an accuracy of 0.84 with a sensitivity of 0.84 and a higher specificity, which met my requirement. You'll notice here that out of 48, it only successfully identified 10. With simple linear regression, I used the same predictors as the naive Bayes model. And that led me to a mean squared prediction error of 0.129, which I thought was acceptable. And with a 95% confidence level, I was able to say that the intercept was between 1 and 1.7. And lastly, that adjusted R-square was 0.23. And lastly, with the random forest model, I used the same predictors as naive Bayes. And then with this same model, I found something that I was not prepared for, which helped me significantly later on. And I'll dive into that in a second. So this model had an accuracy of 83 with a sensitivity of 0.99 and a specificity well below all other models. But what was very interesting is out of 6 that did leave or retire, it found 5. That was very impressive. But the random forest model also has the ability to key in on variables of importance. Using that model, I found the ability to confirm that overtime, stock option level, and job roles played a significant factor in those members that did leave or retire from the company. And that data is represented visually here. On the left, you'll see overtime, stock option level, and job role are skewed to the right. This is a chart showing how I was able to fine-tune the k-nearest neighbor parameter down to a level of 5 in order to achieve the greatest results of accuracy. This chart is a bit busy, I apologize, but it is showing overall job role satisfaction as it relates to specific job roles. And then it's keying in on a bit of work-life balance. So this is a holistic approach. I didn't find it to be extremely useful. But one thing I did find was that it's safe to say that this company is doing a good job of keeping its members' work-life balance relatively good, as you'll see that the red dots are the smallest of all. Here, I wanted to key in on those leading 3 factors again and relate them to marital status and job roles, comparing that with overtime. So what I found was that the divorced members seemed to stay with the company the longest, and then single members who worked in sales or as laboratory technicians seem to leave or retire much more or in far greater numbers than others. And lastly, I wanted to see if personal factors playing a significant role, and you'll see that they really don't. Your married and single members have pretty much the same factors at play here. And then education levels have relatively no bearing at all on who stays or who goes. But what was interesting was that there were only 3 members represented by purple dots that did have the highest level of education. And then this one shows general employee satisfaction. It's just a yes or no sort of binary chart as it correlates to satisfaction. Those members that stayed, those members that left. You'll see that the members that did leave, represented by blue dots, are pretty evenly distributed, with the majority of them being in the first facet. The 2 and 3 facets and the 4 facets seem to be pretty similar. So lastly, when it was time to predict the missing attrition values, I used a naive Bayes model, and then I predicted those missing values and filled them into the data frame. I was able to attain an accuracy of 0.75 with a sensitivity of 90 and a specificity of 0.10, which was not very good. But using the k-nearest neighbor, the accuracy was 92, sensitivity of 0.92, and a specificity of 0.85, which was exceptional. With the simple linear regression, I found the error rate to be 0.09. And then when it was time to predict the missing monthly income values, I used that same naive Bayes model. And with these predictors, I was able to determine that the root mean squared error was 2,700, well below my 3,000. Lastly, everything that I've presented here can be found at my GitHub, and I will make sure that the YouTube link will also be available on that GitHub. Thank you very much for your time.